All right, so let's do some calculus problems. The directions say write the equation of the tangent line in slope-intercept form. So basically, you're given a curve, and you want to take one point on that curve, and you want that line to reflect the slope at that particular point. So the instantaneous slope in the direction of where it's going at that particular curve. So I've got y equals 2x squared minus 6x, and I want to figure out the equation of the tangent line at x equals 4. So step one, well, go back to algebra 1, algebra 2. This is no different than finding the point and finding the slope, writing the problem in point slope form, and then converting that into slope intercept form. It's just the same old, just with calculus. So part one says, well, let's figure out the point. Well, in order to figure out the point, I'm going to plug in x equals 4 into the equation. So f of 4 is equal to 2 times 4 squared minus 6 times 4. So then we do 4 squared, which is 16. So we get 2 times 16 minus 6 times 4. Negative 6 times 4 becomes negative 24. And then that becomes 32 minus 24, or 8. Therefore, the point that exists at x equals 4 is 4, 8. Well, now that we figured out the point, let's figure out what the slope is at that point. We don't do y1 minus y2 over x1 minus x2. We don't do that slope formula. We take the derivative. So what we need to do is find f prime of x. F prime of x is 4x minus 6 using the power rule. So then we plug in f prime of 4. So we want to figure out the slope at x equals 4, and that is 16 minus 6, or the slope is 10. So now that we've gotten that part out of the way, we've got a point, we've got a slope, let's figure out the linear equation. So I go into point slope form. Y minus y1 equals mx minus x1, where y1 is 8, m is 10, and x1 is 4. Are there any double negatives? No. So now I'm going to distribute the slope, distribute the 10, and I get y minus 8 is equal to 10x minus 40. And now I'm going to add 8 on both sides to get y isolated. Now that I've added 8 on both sides, the equation of my tangent line is y equals 10x minus 32. So just to show you what it looks like visually, I got Desmos. So I've got y equals 2x squared minus 6x. As you can see, it's a parabola. And if I plug in y equals 10x minus 32, it's going to touch the curve at x equals 4. So when x is equal to 4, y is equal to 8. X equals, sorry, I got to zoom up a little bit. When x is equal to 4, y is equal to 8, and at the point 4, 8, the slope is 10. So this red line that touches the curve at 4, 8 has to have a slope of 10, and in order to touch it at that point, it has to be y equals 10x minus 32. So that's basically the visual, and that's the curve and the tangent line touching that particular point. Now moving on to problem number 2. Find the equation of the tangent line for f of x is equal to the square root of x at x equals 25. See if you can do this problem independently. Find the equation of the tangent line at x equals 25. Okay, so first things first, you need to figure out what the point is. So if I plug in x equals 25, I go f of x is equal to the square root of x, so I plug in the square root of 25, which is 5. So my point is 25, 5. Now that I've figured out the point, I need to figure out the slope. Go back a few tests, go back. I don't know how to handle the square root. Could I take the derivative of the square root of x? Yes. I know that the square root of x is technically to the 1/2 power. So I've converted this into f of x is equal to x to the 1/2 power. Now I use the power rule to state that f prime of x is 1/2 x to the negative 1/2 power. And because let's just say I want to do this by hand without a calculator, I combine my knowledge of rational exponents and negative exponents. First things first, I can move x to the negative 1/2 power to the denominator as a positive exponent. So that becomes 1 over 2 times x to the 1/2 power, or I just know that 1 over 2 radical x, because the 1/2 power is the square root. So now that that's out of the way, I'm going to plug in the x value that I like. So I want to figure out what the slope is at x equals 25. Done. Yeah. If it's 1 over 2 radical x to figure out what the slope is anywhere, then the slope at x equals 25 is 1 over 2 times the square root of 25. Well, the square root of 25 is 5. So now I've got 1 over 2 times 5. And now I've got 1/10. Now, I know that in algebra they tell you to write this as a fraction. If it's a nice decimal, I love me a nice decimal. So 1/10 is 0.1. Initially I was going to write this as 1 over 10, but I got to be on team decimal for this one. So now that I've gotten my m, my x1 and my y1, let me just make the focus a little bit better. Hang on. There we go. So now that I've got x1, y1, and m, I'm going to go to y minus y1 equals m x minus x1. So now I'm going to plug in y1 is 5, m is 0.1 or 1/10, whichever you prefer, and x1 is 25. Are there any double negatives? No double negatives. So what I'm going to do is I'm going to distribute the slope. Come on, ink. Oh, got to go to a different color now. There we go. So now that I distribute the 0.1, I get y minus 5 is equal to 0.1 times x, or 0.1x. And 0.1 times negative 25, well, that just moves the decimal place one space to the left. So that becomes negative 2.5. Now I want to get this y isolated by getting rid of that minus 5. How do I get rid of that minus 5? I'm going to add 5 to both sides. And now my tangent line is y equals 0.1x plus 2.5. So let me just set that up on Desmos really quick. 0.1x plus 2.5. Okay, so let me just look at the curve. So let's take a look at the square root of x. So let me just go back home. Home gets me back to 0, 0. So notice that the square root is a slow rising curve. We've got 1, 1 here. We've got 4, 2 here, and 9, 3 here, and x equals 25 is, you would think that it would rise a little bit quicker than that, but x equals 25 only gets us to 5. After all, the square root of 25 is 5. Now I'm going to put the equation of the tangent line. Notice as we get, as the x value gets bigger and bigger, the slope starts to flatten out. So if I touch the curve at x equals 25, the slope is 1 over 10. So it touches the curve. Let me just zoom out really quick. Actually, you know what? Zooming in would be better. If I erase this red line, this curve starts to flatten out, getting a flatter and flatter slope. And that is the equation of the tangent line. Okay, let me just take that off. Moving on to problem number 3 now. All right. Now, write the linear equation for the tangent line for f of x is equal to x cubed minus 1. Find the equation of the tangent line at x equals negative 2. See if you can do this problem on your own. Okay, now that you have done this problem on your own, let's go over this together. So first things first, I need to figure out what the point is at x equals -2. So I'm going to plug in f of -2. So let's go with blank to the third power minus 1, where I plug in x equals -2. -2 to the, -2 quantity to the third power, that would be a negative base with an odd exponent, so that's going to be a negative, specifically -8. -8 minus 1 is -9. So therefore, the point at this curve is going to be -2 comma -9. So that's going to be my x1, y1 of the linear equation. Now, I need to figure out what the slope is. So in calculus, the slope is f prime of x, the derivative with respect to x. So let's calculate f prime of x using the power rule. The derivative of x cubed with respect to x becomes 3x squared. And the derivative of -1 with respect to x is 0. The derivative of a constant is always 0. So now that I figured out the derivative at any point of x, well, the one that I care about is x equals -2, so let's do that. So f prime of -2 means I plug in 3 blank squared, where the blank is -2. Now, I got to do PEMDAS. Well, first things first, I've got a negative base in parentheses quantity squared. What is -2 quantity squared? Comes 3 times +4. And 3 times +4 is +12. So what this means is the graph crosses, at x equals -2, the point on this curve is -2 comma -9, but the slope is +12. Wow, that's pretty steep. So that means that my m is +12. Now, let's go into point slope form, specifically y minus y1 equals mx minus x1. So now I'm going to look at my data. What is my y1? My y1 is -9, so I'm going to do y minus -9. And my m is +12, so that goes in for m. And my x1 is -2, so I'm going to do x minus -2. Now I'm going to take a deep breath. Are there any double negatives? Yeah, we ain't got no time for no double negatives. Y minus -9, I don't have time. I ain't got no time for that. That's y plus 9. 12, that's just 12. I don't care too much about the slope being negative or positive, but I don't like y minus y1 or x minus x1 being double negatives. So x minus -2, that's x plus 2. So I've got y plus 9 is equal to 12 times the quantity of x plus 2. So now I'm going to distribute the 12, and I get y plus 9 is equal to 12x. 12 times x is 12x. 12 times +2 is +24. So now y plus 9 is equal to 12x plus 24. So I'm going to isolate the y by subtracting 9 from both sides, getting my tangent line. So y is equal to 12x. 24. If 24 minus 10 would be 14, then 24 minus 9 would be +15. So that is the equation of my tangent line. So let me just plug that into Desmos. 12x plus 15, okay? So I'm going to hide that tangent line. So let's take a look at the curve y equals x cubed minus 1. Notice that it's a snake-looking graph. It goes from, let me get my mouse, there we go. From negative infinity, sort of dances, it bends a little bit. That's going to come in handy in the next test, not this coming test. And then it comes up. Therefore, well, what happens when x is equal to negative 2? Let me zoom out a little bit. We notice that when x is equal to negative 2, the point itself is negative 9. So negative 2, negative 9. Does the linear equation y equals 12x plus 15 touch negative 2, negative 9, and look like it's going in the direction of the slope? Boom. Look at that. That is poetry. That is poetry. In fact, let me make that a dotted curve just to show you. Nope, I won't. Dashed. You'll notice that the red just sits on top of that point, negative 2, comma, negative 9, and has a slope of 12. That's a very steep curve at that particular point. Okay, so let me just delete this, and we'll do 2 more problems. See if you can figure out the equation of the tangent line for y equals 3x squared minus 2 in the square root at x equals 3. That's the next one. Figure out the equation of the tangent line for f of x is equal to the square root of 3x squared minus 2 at x equals 3. Okay, so first things first, I need to figure out what the point is. So that means literally plug in x equals 3 into the equation. Well, first thing I got to do in this square root function is I have to square, I have to do 3 squared. 3 squared is 9. 3 times 9 minus 2, so I got to do 3 times 9, which is 27. 27 minus 2 is 25, so the square root of 25 is 5. Therefore, the point on this curve is at 3, 5. So that's going to be my x1, y1. How do I figure out my slope? Oh, geez, I got to go back to this. Oh, man. So, welcome back, the chain rule. So, recall that we've got f of x is equal to the square root of 3x squared minus 2. How do I make this easy to take the derivative of? So I should use proper calculus vocabulary. How do I make this easier to differentiate? There we go. That's using the old noodle. So this is all to the 1/2 power. Well, if you need a refresher on the chain rule, there's a function in another function. So I'm going to call this green. Now I've made this green to the 1/2 power. Get my... So if f of x is equal to green to the 1/2 power, well then f prime of x, the derivative with respect to x, says, hey, the derivative of green to the 1/2 power is 1/2 green to the negative 1/2 power times green prime. You miss that voice, don't you? So now I'm going to put the green part back in. 1/2 of 3x squared minus 2 to the negative 1/2 power times green prime. So now I'm going to take this inner function, 3x squared minus 2, and the derivative of that, it would be 6x, and negative 2, the derivative of negative 2 is 0. So maybe it helps to clean this up a little bit. So I'm going to pair up the 1/2 of 6x, and I'm going to clean this up by saying, okay, half of 6x is going to be 3x. And using my algebra skills, if I've got anything to the negative 1/2 power, that means that the denominator is the square root of 3x squared minus 2. So that's f prime of x. Now comes the part where I plug in what is the slope at x equals 3. So now I want to figure out what f prime of 3 is. So that's 3 times 3 over the square root of 3 times 3 squared minus 2. So that becomes 9 on the top, and the square root of, well, that's going to be, just to shorten this up a little bit, 3 squared is 9, times 3 would be 27 minus 2. So that'd be 9 over the square root of 25, 9/5. Well, if I have to deal with a fraction, I might as well make it a decimal if it ends. Specifically, 9/5 is the same thing as 1.8. So my slope is 1.8. That took a while. Now, I might need to use a calculator, but still, if I have a point 3, 5 and a slope of 1.8, well, let's go into point slope into slope int. So we've got y minus y1 so y minus y1 is equal to m x minus x1. Or specifically, I'm going to plug in for y1, m, and x1. y1 is 5, m is 1.8, and x1 is 3. Are there any double negatives? I ain't got time for no double, no, there's no double negatives. So we've got y minus 5. I'm going to distribute the 1.8 to the x and the negative 3, so that'd be 1.8x. And if 18 times 3 is 54, then 1.8 times negative 3 would be negative 5.4. Now I'm going to isolate the y on the left side and get this equation in slope-intercept form by adding 5 to both sides. Cancels out, leaving me with y equals 1.8x, 5 minus 5.4, that'd be negative 0.4. So that's the equation of my tangent line, and let's show it. So if this is the curve, y equals the square root of 3x squared minus 2. Let me get that Desmos equation up there. 1.8x minus 0.4. Hide the tangent line. So look at, oh, this is a weird looking graph. So this is the square root of 3x squared minus 2. Oof. And I care about the point 3, 5. Right, so around here. So I care about x equals 3, y equals 5. And this linear equation is going to touch it in the direction of where it's going at the time. So it should be a slope of 1.8, or that should be 9 over 5. So a little bit of a steep slope, but not too bad. If I hide the graph, specifically, let's make this dotted. Look at the tangent line as it touches that blue graph. Let me make them both dotted, see if it makes it easier to see. Notice that if I zoom in, the red tangent line will touch the blue curve at 3, 5 in the direction of where it's going at that time. So I'm looking at the clock, and I don't want to overwhelm you guys. I figure we do 4 problems. In the next one, I'll do the y equals 6x minus 5 to the 4th power at x equals 1. So if you want to do that one right now, figure out the tangent line of f of x equals 6x minus 5 to the 4th power at x equals 1 on your own. But that'll be the next video, starting problem number 1. Have a great day, guys.